Hello Algebra 2. We're here on this snowed out Tuesday, making a video for you for Thursday, or for due by Thursday. So lesson 79 is on metric volume. The key here, 79A anyways, metric volume, is that 1 cubic centimeter is the same as 1 milliliter. That's actually how they do that conversion of a volume or liquid compared to a measurement. So this would be three-dimensional, and obviously a liquid would be three-dimensional. So that's how that works. Really, that even stems from, if you look in the book, the fact that 1 liter is the same as 1,000 cubic centimeters. And that's just, times that by 1,000 is the same, is 1 liter. Times that by 1,000, same as that. Okay, so first part is just doing some conversions. 14,000 milliliters over to liters. That one should be pretty easy. Metric, we know milliliters to liters. That conversion is 1 liter is 1,000. Again, you're just trying to cancel out the units to help you remember if you should multiply or divide. So in this one, 14,000 divided by 1,000 is 14 liters. Nothing new there. The new part is converting 4 cubic feet over to liters. So 4 cubic feet, remember we'd have to cancel out feet 3 times. So we're going to take our conversion from inches to feet, which is the number 12, and we're going to do it 3 times. So to save myself a little bit of writing, I just did 12 cubed and then 1 cubed on the bottom, and that way I'd have feet cubed cancel out right away. That way, otherwise you'd have to do 3 conversions. 12 over 1, 12 over 1, 12 over 1, same thing. Then I want one to get from inches cubed over to, we're trying to get to liters, so I got to get over to metric. We know that 2.54 centimeters is the same as 1 inch. So getting rid of inches, I put that on bottom, 2.54 on top, and since I want to do that conversion 3 times for volume, I went ahead and cubed it. Okay, once for each dimension. 2.54 centimeters to inch, 1, 2, 3 times. Then here, wanted to get from centimeters, now my goal is to get to liters. That's this conversion up here, either this one or this one. Since we're in centimeters cubed, we can convert over to milliliters. So right down here, boom, centimeters cubed, get rid of that, go over to milliliters. Now I'm out of cubic and over into liquid. So now I just have a milliliter. So when I have to do my last conversion over to liters, I do only have to do that 1 time. I don't have to cube it. So to get my answer, I'm going to do 4 times 12, 12, and 12. So either 12 cubed or multiply by 12 3 times, then by 2.54 3 times, and then at the end I can finally divide by 1,000. And I didn't fill that in. Let me get my calculator out and just show you what the answer should be, since I didn't fill that in. So again, in this problem we're going to do 4 times 12 is being done 3 times, 2.54 done 3 times, and then just divide by 1,000 at the end. So divide by 1,000 and your 1,000, enter. So about 113.27 liters is my answer. So I'll go ahead and write that in since I didn't write that in the last time for some reason. 113.27, and that's in liters. Okay, all right, we talked about a 30, 60, 90. For 79B, we're going to talk about 45, 45, 90 triangles and some shortcuts you can use for those ratios. First of all, any triangle that has 2 equal angles, notice these both have 45s. If it has 2 equal angles, it must have 2 equal sides. So if this triangle has 2 equal angles, it must be isosceles. Got to be isosceles. The 2 legs are going to be equal. Remember, the hypotenuse is always the largest side, so it can't be equal to anything else. So it's going to be the 2 sides that aren't the hypotenuse that are equal. So the ratios, 1 to 1 for the 2 legs, because they have to be the same size. It's isosceles. And then using, a little Pythagorean theorem, you can figure out that the hypotenuse is always going to be whatever that is times the square root of 2. Okay? A shortcut, like I used to teach my classes, was the hypotenuse equals whatever the leg is times radical 2. So there's only 2 ways you can ask this question. Find x and y. I can either give you a leg or give you a hypotenuse. This is definitely the easier one. If this leg is 6, then x has to be 6 because they're isosceles. And then all I have to do again here is whatever the legs are times radical 2, that's going to be the hypotenuse. You could, of course, do the Pythagorean theorem, but you're just going to get 36 and 36 is 72, and the square root of 72 reduces to that. So you're going to get the same answer. This is just the shortcut method because it will always happen. Now, the longer way to do it is if I give you the hypotenuse, x and y, we know they have to be the same answer, but to get that, we're going to plug the 9 in here for the hypotenuse equals x radical 2, and we actually have to divide the radical 2 over to figure out what the leg would have to be. And we can't leave the square root on the bottom, so we'd have to rationalize it, so x and y would both be the same number, 9 radical 2 over 2. You could, of course, use Pythagorean theorem, x squared plus x squared. You could use the same variable because they are the same size. And then you can get an answer that way. Okay, lesson 80, we'll hit that real quick as well. We already talked about, as I mentioned over here, we already discussed direct variation. Remind you of what that is. Again, it just means x and y multiply one number. This was the relationship. And actually in class, Sterling brought up the idea of using ratios to solve. So just a quick review, cost varies directly as the numbers purchased. So right there, cost equals number purchased times some number. And then they give us some ratios that we can use. If 12 can be purchased for $78, how much would 42 of them cost? So 12 of them is $78, divide by 12, and this 78 over 12 reduces to 13 over 2. So that's the relationship. That one number to get from 12 to 78 is that. So there's your relationship. Now it says how much would 42 cost. I just have to take 42, multiply that by that same number, and the cost would be 273. And again, reviewing what we talked about before, you could also do it this way. 12 and 42, the items, $78 cost to $273 cost. And then we did the same thing with inverse variation. Remember that was x and y by multiplying or dividing by something. K divided by x to get y. And then we talked about a ratio to do that. Inverse means to flip. So the first fraction, but you'd have to flip the second one. Again, we talked about this in class. It was a good observation we made that made a lot of sense. So there's my example. Again, you could do it the old-fashioned way, or you could do it the way we talked about before in class, or the new way here, which is 100 over b, but then you'd have to flip the squares over here so that it would fit that inverse relationship. All right, so your homework is going to be this lesson number 80 that we just talked about. Lesson number 80, and do 1 to 30 for me for Thursday. See you then.